Hi, this is Robert Yeager, the developer of the WeWired Web. This video is intended for technical people who want to add or modify actions to the system. The WeWired Web is a mashup system where non-technical people can hook up web services to perform tasks. An example of a task might be to call my phone at 9 p.m. if tomorrow's weather forecast calls for snow or severe weather. The WeWired Web is itself powered by a mashup system that is community extensible. Technical people can extend the system to add and modify services, triggers, and actions. Services, triggers, and actions in the system are all created with the assembly editor. Note that when I selected the random pause action, it prompted me for the minimum and maximum pause delay in minutes. Let's see where these parameters came from. Click gears that you see beside items to edit them. Here is the assembly editor. What you see are software parts connected together. Each part performs specific functionality. An assembly diagram represents a runnable program where data is passed from part to part. Refer to the assembly editor help video for information on how to operate the editor. Actions all follow a general pattern. That pattern is that they receive mapped input data from trigger data fields as determined from the end user's mapping. Then they operate upon those data fields by typically invoking a remote API service to perform an update. This action part is unlike many in that the action part has no defined data fields. This means that end users cannot map trigger data into this action. Remember the minimum and maximum minutes to pause parameters? Here they are, defined using stepper assembly argument parts for numeric data entry. Assembly arguments that are flagged as being public will appear in the configuration dialog when an action is selected from the task editor. This action assembly takes the minimum and maximum delay values and uses those as boundaries for the random number part, whose randomized value is then fed into the pause part, which does nothing but to pause the execution of the action assembly. This particular action is useful for chaining multiple actions together within a single task, so that the actions are executed one after another with a random pause in between, which is useful to build a task that mimics a human. Let's see how an action that takes data fields works. The email action needs to receive a subject and a body to deliver an email. Those data fields are both marked as required text fields. You can also see that they have test data entered, which is needed to initially build the assembly and test it. This action loads the end user's email address from the selected account. Each service in the system can be configured with multiple accounts. In the case of the email service, that means each user can configure multiple email addresses. The end user selects which account to use when building tasks. The subject, body, and email address are then extracted and fed into the email part, which does the actual email delivery. So let's look to see how an OAuth web service action is done. Like other actions, the scoopit action starts with an action part that specifies its input data fields. Then, node text extractors are used to extract out individual data field values that are then wired into the OAuth transaction part for each API parameter value. Each API provider will document the transaction parameters and calling conventions needed to invoke their API. This concludes this video segment.